have logarithmic function. Okay, so let us define that logarithmic function first. What is logarithmic function, how it works, and many more things that we will discuss. Okay. So the topic name is logarithmic function, logarithmic functions, and logarithmic and exponential functions. Okay. Logarithmic and exponential functions, and logarithmic and exponential function. Exponential function. So see, we have two types of logarithmic functions that we use. Okay, one is natural log, natural logarithmic function. What is natural logarithmic function? See, when we say natural logarithmic function, that means there is base e, log of x, suppose, and base is e. This base e. E is a constant. E is a constant. The value of E is 2.7182, like this. Okay. So this is called natural logarithmic function, natural log. Okay. And
Okay.
there is one more that is used quite frankly, quite frequently. That is common logarithm. Common logarithmic function. Is 10. Base is 10. Logarithmic to base 10. Okay. So exponential function we have, exponential function, we have fx equals to, say, 10 raised to the power x. Okay. Okay. So if 10 to the power x is suppose 30, okay, 10 to the power x is say 30, then x will be log of 30 base 10. So how we define a logarithmic function? Definition of logarithm. If a to the power b is c, then b is log of c base a. Got it?
So the A is between log and C.
C is the function whose log has to be determined, and a is the base. A is the base. Okay, so we read log C base C to base to base a. Okay, log c to the base a.
Now, if a is the base, why is it written down? Why is it not written on top like a to the power of b if it's a base?
See, this is a question something. Why we take root over 2 as 1.414? Or why do we take e equals to c upon a? Or why do we write uh, a to the power x power at the top, on the top? See, this is something which have been derived from the mathematicians, and they have used such pattern, such way to write the logarithm function. Okay, so simply log of, if we take log of x base a, log of y e a is not at the top. See, if we a will be over here, that means we are finding the log of a, not x. Okay, so this is just a way to write the logarithm function. Base is taken at the bottom of the log, and the function whose log has to be determined is taken at the top. That's it. Okay, there is no such uh, need, or not so, no such rule that it, or any specific reason that C is taken as it. It is just a way to
Understood.
write. So tell me, if y equals to 10 to the power x, then what will be the value of x? Then x equals to
Um,
what?
log 1 over log 1 y base 1
Base 10. Base
base
10.
10.
Yes. X will be log y base 10. Log of y base to the base 10.
So what's the
So
use of logarithmics?
yeah, logarithmic function. We are just in the beginning. We will be discussing all these things. So suppose we have log x. So let us see the graph of logarithmic. Let us see the graph of logarithm. Graph goes like this. Okay, graph goes like this. Let's see the graph of logarithmic function. How it, just a minute. Graph of logarithmic. See, here is the graph of logarithmic function. Are you able to see it? Graph of, are you able to see
Yes.
the Google screen? See, these all are the graph of logarithmic function. So see, one thing that is common in all the graph is that
They're curved.
yeah, they are curved and they pass through 1 comma 0. You can see it. Means one of the zeros of the logarithmic function is 1 comma 0. See, graph is going through 1 comma 0. Okay, graph is going through this 1 comma 0. You can see on the screen. Okay, the graph goes like that. So now coming to definition of the logarithmic function. See, these are the different bases. These are the logarithmic function of having different bases. This one, the right corner, right top, y equals to log base ex with red color graph and log x of base t2 to the base 2 with the green color and so on. Okay?
I
But
have a
one,
question.
yeah,
Do all graphs pass 1 comma 0?
yeah. But log 2x doesn't pass through that. See, that goes to 0.25 comma 0. It depends upon base also. Okay, it depends upon base. Okay, so if we take natural log, that is log x is e, then it will pass through 1 as log 1 is 0. Why it is passing through 1 comma 0? Why it is not passing through other point? Let's discuss this point. Okay, just a minute. See, we have log of 1 base anything. Means if x equals to 1, then y becomes what? Log of 1 base e, which is 0. Therefore, point on x-axis is 1 comma 0. Got it?
Got it.
Because log of 1 base e, the value of log 1 base e is 0. That's why it's possible. Okay. Now, log of x is, let us take it as a, x is greater than 0. Okay, and a is greater than 1 or 0 less than a less than 1. What does it mean? Base can be between 0 and 1, any fraction, okay, or greater than 1. Base cannot be 1. Sujal, these are the important concepts that should be taken care of. That a base cannot be 1. Okay. Now, properties of logarithmic function. Properties of logarithmic function. If we have log x into y, then it can be written as log x plus log y. Okay? Sujal, log x upon y, log x minus log y. Whenever there is no base written, that means base is by default taken as e. Got it?
Got it.
However, we can take base 10 as well. We can take. Log x to the power n equals to n log x. Log of b base a can be written as log of b and base any of your choice. Okay? Base of your choice. And divided by, this is called base change formula. Base change formula. Log of b base a 1 upon log of a base b. These two are called base change formula.
Log to the power of b over a or log b base a.
Log of b to the base a can be written as log b to the base c, log a to the base c. In place of c, you can take any base of your choice as required. Discuss with your classmates why each of these four statements is true. Yeah, log of 10, 1 is 0. See what happens. If suppose we have log of b base a equals to x, that means b equals to a to the power x. Okay? And similarly, if we have log of 10 base 10, this will be what? Obviously 1. This will be 1. Okay? If base and the function whose log has to be determined are the same, then it is always 1. And that means, and also we have log 1 base 10 equals to 0. How it is? See, 1 can be written as 10 to the power 0. And from here we have 10 can be written as 10 to the power 1. Now, coming to exercise 6.1, Sujal. Exercise 6.1. Question number 1, we have convert from exponential form to logarithmic form. We have 10 raised to the power 3 equals to 1000. Okay. So, three equals to log of 1000 base 10. So this can be log of 10 to 10. Got it? Is the answer given? Pick your answer. And Deepak.
Log of 1000 equals 3.
Yes. Log of 1000 equals to 3. Yes, that we wrote over here. Log 1000 equals to 3. We can rewrite it in this form as well. And D, 10 to the power x equals to 2 can be written as x equals to 10 square. Okay, now x equals to log of 2 base 10. F, 10 to the power x equals to 0.06. So x equals to log 0.06 base 10. Question number 2. Check your answer, Sujal. Check your answer.
X equals log of 2. F x equals log 0.06.
Yeah. If there is no, see, base will be 10. Base will be 10. Solve each of these equations, giving your answer correct to 3 SF. Ten to the power x equals to 75. Log 75. Okay. Log 75. And base 10 is there. So what is the value of 75? See, logarithmic table must have been given. Do you have it?
Sorry?
Logarithmic table, log and anti-log table must have been given in your book.
I don't have that. I don't have the logarithmic table.
You don't know. Then how can you find the value of log 75? If you don't have log table, you can't find the value. Check the answer from that side. What is the answer?
The answer is 1.88.
Yeah, so how you get it? You cannot get it until unless you have logarithmic table. So there would be, I think, at the end of the book, second last page, generally logarithmic table are there. Can't you find?
I'm searching for it. It's not there.
Just a minute. Just a minute. Just a minute. Just a minute. Okay. Again, how can you find the value of that? Let me check whether we are able to find the value. But I don't think. The log 75 can be, however, written as 5 square into 3. So further it can be written as 2 log 5 plus log 3. But still you don't have log 5 and log 3 values. And these values are not remembered. Getting me? These are the things for which table must have been given. So solve each of these equations, giving your answer correct. Okay. So we will do some different approach.
I found the logarithmic table and I will send it right now. I have sent it.
Okay, you have sent it. Just yes, this is the logarithm. Where did you get it?
From my phone.
This is anti-log table. Okay. Anyways, there is different approach. In fact, there is also one approach for finding the value. So we will get that value before as use the log or LG key. Okay. See, to finding the log, you have to use the calculator. Isn't it? Got it? LG key, log key or LG key, scientific calculator. It's given in your book, in fact. Not log 1030 can also be written as log 30 or log 30. Okay, on your calculator, it is written. Where is it? Page number 2 of 11. Page number 2, PDF. Page number 2. See, note is there, logarithmic to base 10, and below that there is note. And then there is written on your calculator for logs to the base 10, you use the log or LG key. So if 10 to the power x equals to 30, x equals to log 30. Log 30 can be find by, okay, so you have to use calculator for that. Got it? You need to use calculator log of 75. It is 1.8750, so 1.88. Got it?
Got it.
So we have to use the calculator for this one. I forgot to tell you that. In fact, in India, the students are not allowed to use the calculator. That's why I forgot. Otherwise, okay. So log 75 is what? 1.875. So this can be written as 1.88 up to 3SF. Okay. Now coming to the question now. Okay. Yeah, this is common logarithm. Yes, that's correct now. So log 75 is 1.875. 1. Now coming to the topic. So in this way you can find the value. Now f, 2f. Ten to the power x. Yes.
It's negative 2.30.
Which one?
Question 2F.
Yeah.
It shows negative 2.30, and on the answers it's showing negative 2.30. Yes, same.
Let me check it. X equals to log of 0.06 and base 10. So this will be log of 6 upon 100. And this will be log 6 minus log 10 squared 10. So this will be log 6 minus 2 log 10 10, which is log 6 minus 2. So log 6 minus 2. So we have log 6 log 6 log 6 log 6 and minus 2. So this will be 1.22 negative 1.2218. So this will be negative 1.2322. This will be the answer. Is it?
Negative 2.30.
Negative 2.30. For which one?
2F.
Oh, it is. You saw, I think 3F. 2F is 0.0. Okay, 0.005 was there in fact. I wrote something wrong. No, it's there. 0.005. 0.005. Yeah. 0.005 was there. I wrote 0.06. Okay. So I took wrong question. 2f is 10 to the power x equals to 0.005. So this will be x equals to log 5 upon 1000. So this will be log 5 minus log 10 cube. So this will be log 5 minus 3. Log 10 is 1. Okay. So log 5 is what? Log 5 log 5 is 0.698, 0.699 minus 3. Okay, this will be negative. So minus 3. This will be negative 0.301. Okay, this is the answer.
No, it's negative 0.2. Is negative 2.30.
Negative 2.3. Okay. Negative 2.0? 2.30?
No, it's 2.30.
0.699. Just a minute. 0.699 minus 3. Yes, it's 0.2301. Correct. I did not write it. 2.301. So you can do yourself this question because you just need to use the calci for the value. Third. Okay.
Is there an impossible way of solving this without calculator?
See, without calculator, you have to find at least value of certain values like 5. How will you find the value of 5? Either you have to use the table, log table, okay, or you have to use the calculator. You can use the log table as well to find the value.
Who invented logarithms?
Hmm?
Who invented logarithms?
Your voice is cracking, not coming properly.
Which mathematician invented logarithm?
Napier. Okay. Now question number 3. A. Log So this will be 5 log 10, which is 5. Answer. Take Okay, what we can do, if we have log 10 to the power 5 into 5, then 10 to the power 5. Log 10 100,000, okay, equals to 5. Then this will be 10 to the power 5. This is exponential form. D log x x equals to 10 to the power minus 0. Got it?
Got
Check your answer.
the answer is which question is this?
Answer is
Question 5A.
third D, 3D.
3B.
3 D
It's
for Delhi. D for Delhi.
3D or 3B. X equals 10 to the power of 7.5.
Which question we did? We
D.
did something else, in fact. I did 4D. It is 4D actually. What happens? PDF in. Okay. So now 3D. Check the answer of 4D also.
4D it's 4D
D. Yeah.
4D 0.501.
4D, D for the D. Here it is D. This one. X equals to. Let us take 3D. X equals to 10 to the power 7.5. You tell me what will be the answer of D, C, B and E. B and E.
For B, X will be 1 and E, X equals 1.7.
For B, 10 equals to 10 to the power 1. And X equal for E, it is X equals to 10 to the power 1.7. This will be the answer. Doing question number 4, A part. And so on. Okay, Sujal?
Understood.
So do as many as